All right, Learning Target 6 video is all about identifying the independent and dependent variable. And if you think back to like the first video from this unit, we talked about that with like the altitude and the temperature. We also talked about it as like a time, speed, distance kind of thing. So this is not necessarily like a whole bunch of new information. It's things that you already know how to do. And so basically what this video is going to be is 3 examples, and all we're going to do is identify variables. And then there will be a before class, and we'll go from there. So in example A, it says Stacy is selling bracelets to help support her favorite cause. She buys a box of bracelets for $15, and she sells them for $2 each. So in this scenario, she's selling bracelets. First she buys a box and then starts selling them. So the independent variable is the thing that changes. It's the thing that doesn't depend on the other one at all. So the independent variable in this case is how many bracelets Stacy sells. And then for the dependent variable, we're going to look for what does this affect. So if she sells more bracelets, what happens? If she sells less, what happens? And the thing that affects is her profit. That she then gives to her favorite cause. So the profit is the dependent variable. It depends on how many bracelets she is able to sell. So if she sells a lot more bracelets, she's going to get a much higher profit. If she doesn't sell many bracelets, her profit is going to go lower. So the profit directly is impacted by the number of bracelets she sells. The bracelets don't matter on her profit. So it's not like if her profit goes up, then she all of a sudden just starts selling tons and tons more bracelets. Okay, the bracelets is independent and is not affected at all by profit. Example B, a minivan is 220 miles from its destination in Flint. Flint is a town in Michigan. And the minivan begins traveling towards Flint at 72 miles an hour. So especially with this type of problem, I almost always draw like a little picture. So there's my minivan that really just looks like a shoe, and it's going towards Flint. And it starts off 220 miles away, and it's going towards Flint at 72 miles per hour. So in this case, and we're not even going to like solve this problem necessarily or ask any questions about it. All I'm curious about is the independent variable and the dependent variable. Okay. So the dependent variable, we'll start backwards this time. We'll look at the dependent variable. The dependent variable is whatever you are measuring. And so the dependent variable would be your distance from Flint, and your independent variable is time spent driving. And so the longer time that you spend driving, so as time increases, the distance from Flint decreases. Okay, so as time goes on, you get closer and closer and closer to Flint, and your distance goes down. So that's a similar relationship, except it's sort of inverse. Like as the time goes up, the distance goes down. Example C is sort of different. Example C is Devin is going to the carnival, and wants to ride on the rides. She has $20 to spend and wants to ride the Ferris wheel and the zip line. The Ferris wheel costs $2 and the zip line costs $4. So she has 20. She wants to ride two different things, and if the question is sort of like what kind of combination of Ferris wheel rides and zip line rides she can do, then the two things we're interested in are number of Ferris wheel rides and number of zip line rides. And in this case, the two variables are not independent and dependent. Like, they don't affect each other. So the number of Ferris wheel rides does not necessarily affect the number of zip line rides, unless like you ride the Ferris wheel a whole bunch of times and like puke all over the place, and then you don't want to ride the zip line anymore or something. But that's not really, like, that's kind of far-fetched. So in this case, the two variables really have no effect on each other. And so you can sort of think of them as both being independent, and these can also be interchanged. Okay. So your before class is to sort of write your own story problem. And you can write whatever you want here. Hey.
Hi.
You can write whatever you want here. And then your partner is going to pick out the independent variable and the dependent variable. Okay?
Okay.
Cool.